Well, good morning, everybody. Thanks for joining. I guess it's morning, but technically it's lunchtime. But thanks for joining us for our next Wednesday or Thursday webinar as part of our inspection series. And today we're going to be taking a look at inspecting specifically mechanical systems for energy code compliance. So I do want to go ahead and apologize up front. I'm doing this from the inside of a car, so it's a little bit difficult to see the chat feature. So if you do have questions, please make sure to throw them in the Q&A, and if I can get them, we'll get to them. Otherwise, just if you put them in the Q&A, then I'll make sure I take time to fill them out once I get to a better place where I can sit and actually read them. And so, but if you do have questions, feel free to reach out throughout the process, or again, reach out to us individually so we can help you with any questions you might have. But if you do aren't already visiting the Excel Building Energy Code Support Program website, make sure you do. There you'll find a variety of different resources, our newsletters, technical documents, our videos from past trainings, and really we're trying to find a way to best make available to you and to the contractors throughout the Panhandle these different resources to make sure that we can have efficient and code compliant construction methods and practices. But as we talk about today and looking specifically at the inspection process associated with mechanical systems, I think it's important, as I always do, to reinforce this understanding that this belief that if we understand the why we do it, then we can figure out the how we do it. And when we think about why we do it throughout both the commercial, residential codes, we understand that part of building a minimally compliant building means looking at more than just the amount of light we provide, the amount of ventilation, but also how we provide it, right? Do we look at making sure we're energy conscious about those decisions we make in that design process, recognizing that energy consumption is a major cost for in consideration in property development, community development, building safety, building longevity, all those different components. You know, part of energy is one of those things that we always have to think about in how we build buildings. But when we start to think about it from the perspective of today's conversation, I think it's important to understand that the purpose behind the mechanical code is not to tell us necessarily the best way to accomplish ventilation and space conditioning, but more so to provide us some basic minimum expectations for protecting and controlling those systems and how we ventilate, condition, and our occupied spaces or habitable spaces. So whether we're looking at the IMC, we're looking at the mechanical provisions within the traditional residential code, we're looking at how does all this system work together in order to operate and effectively produce or facilitate habitable buildings, right? We can't have buildings if they don't have ventilation, if they don't have heating and cooling. We can't have truly code compliant buildings. And so that's one piece of today's conversation that's really focuses us in our conversation about energy conservation, right? Remember, the energy code is about being efficient through flexibility and innovation. It's not telling us this is the only way to build. It's saying, hey, we give you options. We want to make sure that you think about the entire building in the process. And so that's when we think about everything we'll be talking about today, you'll hear it over and over, and you've heard it over and over in the various different conversations we've had before about the role of flexibility in that design and process. So when we think about what it means to be code compliant, or how to facilitate or really move ourselves towards overall project success, I've said it before and I'll say it again, it all to me begins on paper, right? It's understanding what our expectations are and properly making sure that they're lined out, right, in those drawings. Probably the some like different meanings there, right? But when we draw out what it is we're expecting, we review that plan for code compliance. because we understand that the goal is that this building is built to what those approved plans are going to be. But regardless of what we do to that paper, it really requires us to do inspections to verify it all the way through, right? Because we can't just sit in our desk and use binoculars to visualize or to effectively control a design. Now, I'll tell you, the last time I was in town, there was a beautiful building going down behind my hotel, and I could have sat there all day with a pair of binoculars. But that was in the demolition phase. In the reconstruction or whatever they're planning to do with that facility, that parking lot behind the embassy downtown. Again, once the walls go up, I am not going to be able to use my binoculars and watch that process effectively. I'm going to have to, if I was the inspector, I'd have to be there to see what's going on. And that's what we're really going to talk about is what are we doing and what are we trying to accomplish in the field to verify code compliance. Now, I've talked about it before. To me, there are those 4 basic pillars of energy code compliance, and those are going to be our building thermal envelope, the air barrier, the mechanical systems, and those power and lighting considerations or controls, right? But in today's conversation, we're really going to focus obviously on the mechanical system. Now, we know that within the energy code, there's a variety of different expectations within the chapter or section 403 for mechanical systems, but we're not going to go too deep, right? We're going to look at it in the context of what are some basic expectations, some fundamental understanding of how we perform field inspections as part of that system. And we're going to do a lot of that based off of the field guide that we've talked about in the past. I think back when we were there, what was it, June? Or maybe it was April. Can't remember. But again, within that document, there were certain components that are part of that mechanical system. This is not supposed to be a holistic listing of those expectations as much as it's supposed to be a basic tool that we could use to say, to maybe provide to our contractor to say, these are the things I'm looking for when I come out as an inspector, right? This is the things that really get to the nub, the reason for why we build and do the things that we do. And so that's kind of how we'll take a look at this throughout that process. Now, with any project, you know that I think one of the fundamental things to understand from the beginning, and it's recent, it comes out in the 2021 edition. So in the 2015, on 2018, this is not an enumerated listed item in section 103.2. But in section 103.2, under that list of information that's supposed to be provided on the construction documents, is this expectation that we provide that compliance path, right? And the reason I think that's important to understand as an inspector is because it's going to give me some guidance on what I'm expecting to accomplish, to see in that building, right? Am I expecting this to follow a prescriptive path, which is that just do what the building says and leave me alone? Do what the book says, leave me alone. Or are we looking at one of those performance alternatives, right? Whether that's a total building performance mathematical calculation costs of operation versus an energy rating grading of it. And the one thing that we have to understand is in the model version of the 21, remember, we're supposed to provide prescriptively, we're supposed to follow one of those additional efficiency options. And so in some instances, we may be choosing a additional efficiency option that requires us to have a more efficient mechanical system. And so we can't just go out there and say, well, it's prescriptive. I just have to look for an 80% furnace and I'm done. Well, let's slow down there. It might be a little bit more than that because again, what's the full image of the building? So why I think again, it's incredibly important to have that full understanding of the plan review process, and then we're verifying that in the field, right? So if we've made those connections out in the field, out in the plan process, then we're verifying in the field, then we're not going to have those missed moments where, well, they said it was going to be a 95% efficient furnace, but it's okay if it's an 82 because it's fine, right? It's better than 80. Well, maybe it's not because of either because of those compliance path decisions. And so, I could spend probably, well, I've spent hours talking about, compliance paths and those kinds of considerations. So I'll leave that alone and we will get back into the real nub of today's conversation. And so beyond just having that list, of a significant portion of the things that we find in section 103.2 is relate back to our mechanical systems, because again, those are critical pieces of the building. It's I had this conversation this week, with someone the other day about the next iteration, next generation of this conversation is not about better insulation. It's not about better air sealing. It's about how we use the mechanical systems to effectively heat, cool, and ventilate our buildings. And that's because that's really where you use energy. We use energy to make certain types of materials, but we don't actually use energy when we're talking about insulation or windows. We're using energy when we power those mechanical systems. And so that's a critical reason or rationale for why we have the conversations that we do. But when we apply the mechanical provisions to our project, we've talked about this in the plan review side, right? There's certain things we're looking for. And I've always, again, I'm a simple person, so I keep it to 4. I have 4 fingers on one hand for a reason. I figured that means it's because I'm supposed to look for 4 things. And so when I think about those 4 basic expectations of a plan, that I'm looking for, again, a proper design with proper size of equipment, the specific efficiency of the equipment that's being installed, a set of distribution duct systems that are effectively delivering that conditioning capacity to the appropriate rooms, and a system for controlling that duct system, right? What are the controls? So those 4 basic theories that I'm looking for in plan review, I also look for when I'm doing my inspection, right? I'm looking for that same evaluation. I've approved a size, I'm verifying in the field. I've approved an efficiency of a level of equipment for that equipment. I'm expecting to find it. I know there's a duct system that's been designed and laid out to do certain things and provide certain amounts of air. I'm going to verify that. And then there's going to be a control system, right? We just can't let it, run 24/7 if that's not the design. So again, there are certain things I'm looking for. And it's not just because the plan says it, but it's also because the code says it, right? We know that the code tells us in the residential provisions that there's going to be some level of natural ventilation or mechanical ventilation that exists to provide us with a safe and habitable dwelling, right? And beyond just the ventilation requirements, the code also says we have to provide a level of heating to those buildings to make them occupiable. We know, and I'll get out my laser pointer, we know, we've talked about this before, that when we talk about that heating load calculation in the mechanical code itself, it specifically reminds us that we're not just, now the residential code says we have to provide heating. Heating is required, but the mechanical code says that if we're going to have cooling systems, then those cooling systems have to meet that design load, right? And it gives us some standards that we use to calculate that heating cooling load. But ultimately what we're looking for in the end, so I understand as a plans examiner, I do certain evaluations of the process, or again, if I'm doing that as a field inspector, right? There are certain things I have to understand are being done in that building to get me to the right design. And what we find between the IMC and the model IRC is that what we're looking for is an evaluation of that system. We can't just say Murray said it'll work because he just knows, right? Murray Houston from Houston Air is not the one who's going to say this works. Trust me, right? I'm going to need some kind of some manual J calculation to say this does match the design. And so as an inspector, I'm not recalculating that number. What I'm verifying is that the conditions that existed in it are still applicable. Now, there's a lot of this is done by plan review, but some of this, again, I'm going to be doing double check when I'm in the field. Now, obviously, there's going to be parts of this that are easy to understand. I'm in the right town. Got it. Done, right? But by understanding that there's more to that manual J evaluation than just looking at, well, they did it and it's done. I'm looking at how that load was recognized. Now we provide a variety of different resources to help guide through that system of manual JS&D analysis. But what we're looking at is a heating cooling analysis that says I'm going to have a load and I'm going to have equipment that meets that capacity in order to demonstrate compliance. And so when I'm out in the field as an inspector, I'm making sure that what is there matches with what I find in the field, right? What's in the field is going to have to match what I'm finding in that original submittal packet. You got a permit because it met the requirements of the code. Now I need to make sure it's actually installed properly. So that's a part of that process that I'm going to do as an inspector. The same way when I go out and do an inspection, I'm not just saying, well, yes, there's a building. I'm usually making sure that the occupancy matches what we evaluated when we did that plan review. I'm doing the same thing. If I walked into a residential dwelling and it looked and there was, medical equipment and, or jail cells, I'm going to hold up my hands and go, wait a minute here. Something doesn't quite look right. And so I'm going to do this, this doesn't look like a dwelling unit. This looks like a medical facility, or it looks like a jail, right? I'm going to hold up that project and try to understand where something went wrong. Same process when I'm looking at it from a mechanical inspection. If I'm expecting this to be occupiable space specifically, then I'm looking for where's the vent. Well, we didn't put one in here. Well, why not? How are we getting air and ventilation to it if it's not vented? It's not served by a supply duct. How are we doing this? Because my plans show there's supposed to be a duct. It looks like there should be a duct, but there's no duct, right? Same thing when it comes to that equipment. My plan shows that there's supposed to be a particular piece of equipment that has a certain rating and efficiency, and I show up on site and it's not there. I'm going to have to ask that question: why is it not here? Same thing when it comes to, again, the wall design. If I know that this wall, we've gone through the painstaking process of reviewing that plan review, at plan review, to make sure that we have the R11 wall system, or again, we have got that R19, R15 in this set of below grade walls, right? Or R19 for this below grade wall. I know there's certain expectations that we've talked about throughout the entire design piece. Now we get to the field and I need to make sure they're still there, right? Again, hopefully it matches with what I've got on my design sheets. And so again, these are all pieces that work together to design a building, right? And that overall gives us an example that we're able to build on. Wow, there's my little pun for the day, right? That again, that says we've not only thought about the design, but we've actually laid it out so where we know that we're going to have the right amount of airflow in the right locations. And again, this is one of those things that if I saw this design and this was not consistent with the layout of the building that I'm standing in, I'm going to have some questions. If I've got a U-shaped building and only I've got this non-U-shaped design, well, what's going on over here, right? I know that, again, is it because we've got some, changes in the design? Is it because this is an addition? There's going to be compliance considerations that I'm going to be evaluating. And again, when we go back to that table we've been talking about, it's all, not only am I looking for the equipment size, the equipment efficiency, but quite honestly, I'm looking for even the equipment itself. If I'm expecting a radiant floor system and I show up and there's a forced air furnace instead, I'm going to ask some questions like, hey, this seems like a pretty significant change to go from a radiant system to a forced air, or go to a just straight I'm going from electric to gas, right? That seems like that's a jump that I'm not sure I'm understanding what happened. I'm not saying you can't do it. I'm just saying I need to understand what happened. Because what I'm inspecting and what I'm expecting is what's on the plans. And so if I've got a manual J and I've got a res check that says, hey, we're supposed to have this air conditioner that's going to be 15 SEER and a furnace that's 92 SEER, 92 AFU, 92% efficient, and I show up to the design and I've got a 96%, okay, we got more efficient, but I've got an 8.5 SEER, right? Or a 16 SEER 2. How does a 16 SEER 2 correlate to a 15 SEER? Yeah, I'm not doing the math on this. So someone's going to have to show me, verify for me as an inspector that this is the right piece of equipment. Because I'm expecting a piece of equipment that's going to provide an output of 77,000 BTU and is 96% efficient. What I'm not expecting to see is an 85,000 BTU system, so even more output, or again, 148,000 BTU, right? I'm expecting 85, and again, this is where we would have consistent questions. I've got a heating load calculation that says 77 is what that equipment is going to do, right? I've got a schedule on site that says 85, not 77. So somehow we picked a different piece of equipment now. And then and then when I'm in the building, I'm seeing that it's twice as big as what it was supposed to be. So now I went from 177 to 148,000 BTU, and I went from a 96% efficient to an 82% efficient. I think there's something has changed here. And is it because we're following a prescriptive path, performance path? I'm not really sure. I need some information, right? Because I'm ultimately going to compare that in a traditional prescriptive manner. I'm comparing that efficiency against what I'm seeing in the national DOE standard, right? I know that in the southeast, southwest region, I'm going to have different. We're in the southeast, so I don't know why I put southwest, but we're in the southern region. I know what my SEER levels are, my seasonal heating factors, right? Seasonal heating performance factor. I always get that number back, those initials messed up. But anyhow, I know what that rating is supposed to be, but I'm not getting that in the field, right? I've got the unit that was identified at 21 SEER in this particular example, but when I'm on site, the equipment is a 15 SEER. It's not the same. It's not it's non-compliant. It's one of those I consider a relatively simple concept. What I'm expecting on this plan, I'm expecting in the building. And if there's differences in modification, then someone needs to explain to me what's going on, because we approved this, and I'm not sure this was within that confines. Now, one thing I am going to tell you that I've had a lot of conversations here recently, and I actually had one last week with a friend in Virginia about was the impact of refrigerant changes on some of these evaluations as well, right? They're taking, and even their department over there is taking a lot of extra time, I guess maybe the right way, or making sure they make clear when they notice that a project identifies an R410A refrigerant, and making sure they understand that there may be, especially in residential, the potential that you're not going to have that refrigerant, and that you're going to replace that you'll be getting a replacement of an R54B A2L refrigerant, and that has other considerations that go with it. I'll call it that. And one of the things that, when I was talking to them, they were talking about, part of their process is just recognizing and reminding those designers and those contractors, hey, you can go the rate you're going. We can mark it as a 410, and if you get it, great. If you don't get it and you haven't addressed it up front, then you're gonna have a future slowdown period in your project's development, right? Because you're gonna have to come back and get reevaluated.
for a change, a plan revision, and that you might have to do some things for that A2L that may affect other components or time frames. And so again, it's evaluating that equipment is more than just looking at efficiency. It's more than just looking at the size. It's looking at the whole package together. The refrigerant, the fuel system, the connections, right? I've not gone out and done an inspection on a furnace or system, not knowing what I'm expecting, right? I know when I walk out, is this going to be a boiler or a forced air system? Am I looking at gas? Or am I looking at electric heat, radiant floor systems, or baseboard heat? Whatever I'm looking for, I know from the beginning which one is going to be which because again, it's on the plans. And when I show up and I'm expecting a boiler, but I find something that's a geothermal heat pump, I start to ask questions like, okay, what happened here? Right? Is this were we mistaken? Was something not in there right? And what I don't like to hear is, well, the owner at the last minute made a change. Right? To me, when I hear the owner made a change, that means somebody didn't do their somebody didn't contact me because I need to know about the change, not just the owner, right? Because it may have other implications. Same thing when we start talking about again these different water heater expectations. The code tells us that water heaters have to have a certain efficiency rating. Again, whether we're talking multifamily, commercial, or again, if it's one of those ones that fall under the residential provisions. But what I would really be surprised in is if, again, I'm identifying in this plan, we're going to have a 50-gallon tank that does about 100,000 BTUs and 128 gallons per hour. When I show up on site, it's a 500-gallon tank with a million BTU, right? Like it's 10 times as big. Now the code doesn't say you can't get bigger in the context of tank size, but what it does say is that we need to know what's going in so we can properly evaluate it, right? And if I was thinking about this in any other way, if I had a project that had multiple water heaters, right? You've got a small water heater, maybe an Insta Hot, maybe around the kitchen, but you've got a normal traditional, storage tank for the bathrooms, and those got swapped, right? Especially if it was a large difference between the two. Then again, I would expect to have questions. If my plan shows this half the house where these bathrooms are all served by a storage tank, and there's not a storage tank now, there's a what there, you've swapped these. Not just did you replace them, but you swapped them. I'd ask, did you put them in the wrong spot? Are you sure? Because this is supposed to be a this and this is supposed to be a that. So again, part of this is more than just asking, you know, what piece of equipment it is, but it's also asking the question of what size fuel line are we getting in some of these designs. Now, this to me is one of those important things to ask. How did you size this piece of equipment? Because it's not a lot of times what I see is that we sized it for a particular design and it's not designed for modification, just ready-made modification, right? If we look at a very basic home, right, that's got a simple range of furnace and a water heater that all operate off of a gas line, then we've sized that gas line historically and then even in today's design to meet a specific size of gas load, right? We've loaded the components. We figured out the right size piping based on the length or some other engineering methodology. We've got a regulator at the point of delivery that again may be sized to address just our needs or our pressures. And if we start making these modifications, and for me, this really comes out in Chapter 5 of the Energy Code, we start talking about replacements, repairs, remodels, alterations. We start moving things around and we swap out that 45,000 that click too hard that 45,000 BTU 40-gallon water heater with an instantaneous water heater that has an output or a requirement for 199,000 BTUs. That's 5 times the amount of gas. Did we change the size of the fuel line? Well, no, because nobody said that we needed to. We just figured we could keep it the way it was. Well, that's not how this works, right? We understand that. Excuse me. Sorry about that. But when we think about that system, we're not asking the question of, you know, what do you think it should be? We have a mathematical or an engineering methodology for saying this is the right size pipe based on that. And so when we start changing things, the energy code is just a reminder that, hey, we need to double check this. Becoming more efficient in your equipment doesn't mean you get to give away the safety components that go with it. And when you think about really what I see a lot of times is what was a very simple layout is now starting to get more complicated as we get not only a range and a water heater and a furnace, but now we're getting gas grills or maybe fireplaces or other equipment, maybe a sauna. Who knows what's coming in where we're using additional gas, and are we calculating that in our original design? So again, thinking about what we're doing in that inspection process, we're looking at more than just, again, the size of the equipment, the efficiency, but again, what is it and how is it functioning? What's its purpose and those kinds of considerations. But then that leads us into this next part of the conversation about ducts distribution and control. And so when we start thinking about those systems, the one that draws my attention first in that layout or in that consideration is what we call here a mechanical room. Now, what I'm talking about when I say mechanical room is making sure that we understand the relationship between the mechanical room or wherever the appliance is and the thermal envelope. Now, remember, the code requires us to make sure that that thermal envelope is continuous around that equipment room when it gets its combustion air from an uncontrolled venting system, right? So if it's getting uncontrolled, untempered air directly from the outside into that combustion area, then we need to make sure that we're not allowing that air to migrate into the surrounding conditioned space and cause heat loss. I mean, it sounds like a simple concept, but again, the code makes sure that we evaluate those types of things. Same thing when we look at, again, where's that envelope in relation to our commercial designs? And I know we don't always talk a whole lot about commercial, but at the same time, when we start thinking about where we locate the ducts in relation to that building thermal envelope, we also have to understand what is the expectation of that space. I've used this example before in some different conversations. And so this was originally a building designed to be a large storage facility. And when I walked in, it was more than a storage facility, but it had turned into a series of 40 different offices that were built because they were running out of space in the main building. And so when you look at, so we've modified this space from an S2 to an S2 in an M or an assembly space, right? Depending on office space. And so when we have this office space, this non-storage area, we have to evaluate the equipment that's been assigned to it. Now, again, when we think about the building, we've put in a couple, condensing unit, but we still have one gas-fired heater. With that condensing unit outside, and we put that gas heating unit right in the inside of that storage unit. So again, are we thinking effectively about how we're going to heat and cool this entire space? Now, I'll be honest, again, this entire storage area is going to be heated by one gas-fired unit, right? That's, a little bit of concerning to me. And I want to, and again, this to me would be those opportunities. And again, as an inspector, I look at this and I say, this is not the way it was designed. And so when I get this plan revision back, I ask that question. Wait a minute, what's the design? What's the heating load calculation? It's the same. No, it's not. You added 40 offices in 2 buildings. And I'm assuming, and I did because, again, this was the way it was designed, you lost a heating unit. So you got rid of a heating unit. I'm sure that had to affect it, right? And so again, understanding where everything is, what's there, is really part of that critical assessment of mechanical equipment. I could digress on this for an hour, but again, and it's more again than just looking at where it's located, but it's looking at the relationship with that duct system and our thermal envelope. We see in this orange line, the building thermal envelope, we see some thermal separation between that above ceiling area and those offices in that corridor. And that's where those blue duct systems are. So are those in heated spaces or conditioned spaces or non-conditioned spaces? Well, we see that it's an open area between the storage parts area and that above ceiling space. So in reality, it's a semi-heated, unheated area, unconditioned space, because we don't have adequate vent control over the entirety of this space. We've got, again, docked areas. We've got docks here, dock there, that are again allowing, where there's a variety of things we're looking for, and we'll talk a little bit more about that as we go. But again, these are things I'm looking for to see where is it in the relationship to that building thermal envelope, and how are we properly sealing that mechanical space? Because again, when I get out to do that inspection and I don't see good separation, I'm thinking this is all one building, all one conditioned area, when in reality it's not, right? We've got some separation between the office area and the service bay and those other ancillary, spray booth and what we see here is a wash bay. And then when I go do those evaluations of those pieces of equipment, again, I'm seeing 2 gas-fired heating units in the wash bay, a thermal separation here, a fan, and 2 gas heaters in the spray paint booth with its exhaust system. And that's going to be different than what I'm seeing when I look at, again, that service bay, where I've got multiple fans, long heating unit elements, and ventilation, and a series of different controls to make sure things operate when they're supposed to. And if one of the things that you'll notice if you read those controls is it gets into how that door switch, or those doors, those overhead doors that we see along that service bay for this RV dealership, how those affect those fans and heating units and exhaust fans. And what are some different CO2 or CO2 detectors that are going to then activate some of these different exhaust components? So again, it's a little bit more than just saying, yes, I saw there's a fan. It was plugged in and it was properly wired, properly secured, anchored, and it worked, right? It's also about checking those systems, which again, to me, drives us back. When we're talking mechanical for commercial, which I know we don't do a whole lot of in that conversation. When we're talking about mechanical equipment and commercial operations, sometimes those require commissioning, right? They can require that special review to make sure that all of the components, all the controls, all the devices work appropriately. It's not like we're going to stand there and walk every room, hitting every switch to make sure every fan turns on, or we're not going to breathe into it with enough carbon dioxide to force the fan to activate, right? That's what we have commissioning agents for. And so again, I'm doing my role knowing what's expected on the other side before final certificate of occupancy. But that's not just the end of the conversation when it comes to what I'm expecting, right? I'm thinking not only about the space conditioning, but also the ventilation. And so again, if I'm doing that ventilation evaluation that's required by the mechanical code for both the residential and for commercial buildings, right? We talked about whole house mechanical last week. What I'm doing is I'm looking at those sequences, those controls, to say, how does it all work together? How does it balance to where I don't have unfettered, or continuous exhaust fans operating continuously that are then drawing out the heat loss, so that I now have to bring in more tempered air and spend more energy to maintain the existing temperatures. So again, these are considerations, especially when we're talking about resident and commercial. If we've got a hood system, we want to make sure it properly set, when it's inactive, it's properly dampered, right? To make sure that, again, we're not losing air uncontrollably. So that makes me think too about our duct system, right? We're looking at the ducts, and we understand that the mechanical code explains to us, gives us a set of, and the fuel gas code both provide us a system or a listing of different types of expectations associated with ducts, whether they're combustion air ducts or they're going to be part of our supply or return ducts. And so ultimately what both of those codes are really driving us towards is recognizing that if we're talking about dwellings in the IMC, we're looking at that manual D. If we're looking at non-dwelling units, then we're again going to go back to manufacturers' installation structures, approved designs, ASHRAE Book of Fundamentals, other types of computation systems to determine how much air are we moving through that duct. Because again, it doesn't matter how much we put into the duct if we can't get it back out at the other end, right? And that applies to both residential and commercial. And so when we think about that residential system, we're looking at how does the whole system work together to get me the air, to get me the conditioned control space, conditioned air where I want it, right? Again, how am I effectively and efficiently operating the building? Now, one of the things that I like to put whenever I do plan review and I think about my inspector, and again, having done inspections for a long time, the thing that really I think is important for us to think about in residential designs, a lot of times this is not something we get from the very beginning. And so it takes time to get that understanding within our designers that not only do I want to know the amount of CFMs of air going to each of these different vents in those different rooms, but I also want to know what those different fittings, boots, and terminations are going to look like, right? I don't know how many times at the beginning it was I would go out there and it's like, I know there's supposed to be a T here. Is it the right T? I don't know. Is this the right Y? I don't know. Is this right 90? I'm not sure. All I know is that the map shows it turns, so that must be the right one, right? And when we think about the actual design to a standard like Manual D, that process is a lot more complicated, a lot more involved, not complicated, but involved than just a plug in and let it go, right? It requires the designer to take the time to recognize what is the capacity of the equipment, what is the different heating, loads, the ventilation requirements, the types of static pressure, the size and design of those duct systems, right? Are they going to be round ducts or square ducts, or what are we doing with them? So again, those are things that we need that go into the original design, and so in that consideration, they need to come out in the actual project, right? So we know there's an equivalent length or a length of the duct systems that we're really, trying to get to, right? We understand that supply is 210 feet long and is 65 feet in that return. And so we want to make sure that when we actually design it, that's the right building, the right extensions. I've talked about before, my home I like to use my home as an example. I have a utility laundry room at the end of my home that is the most uncomfortable room in our home. Why? Because it is the longest duct, the furthest away, and it's and that duct register is in a bad location. It's in a corner. So it's not going to get good circulation, right? It's just not going to happen. And so again, thinking about that, and how does that duct location compare to what was that original design? Is it going all the way to the window, or is it going somewhere in the middle of the room, right? And what are we expecting? Are we just saying, hey, as long as it's in the room, that's all that matters? Or are we going to be, consistent in how we understand those buildings to operate? And again, here's an example of those 11M, that we see that identified on these little, looks like, maybe a Y or something. And then we've got some different, values and names. I don't know what those are. And so again, I'm going to want that diagram to show me what I'm expecting to find when I walk around looking at the design. Same kind of concept here. Here we've got some ideas. I'm assuming, and I hate to assume, I love to assume, right? But I'm seeing some lines that seem to appear to reference flexible ducts versus, circular or straight ducts. I'm assuming a 6-inch means a 6-inch round, but I don't know. Is that an oval? Is that 6 foot wide by 6 foot tall? I don't know, right? I don't know what a 4 AD is. You know, I see a 12 by 4, which I'm assuming is an inches of a diffuser that is going to, or a vent that's going to go into a system. But again, and I see the CFMs, but I don't know what a 4 AD is. Is that a termination, a cap, or what? So again, we need to know what that is in the context. And whether that's, again, residential or commercial. And so when we think about the uniqueness of some of future designs and the way designs are coming, where I see more and more where we're starting to see that RIA system, where we've got a more controlled environment or controlled distribution than our standard old, you know, main trunk line that then ran off, you know, and fed a bunch of rooms. So again, we're seeing different designs come out, but ultimately when we think about it in the context of what we're doing is in our inspection practices, is we're making sure that layout matches, right? If I see a 10-foot line or 10-foot equivalent length identified, and I've got a 20-foot long, you know, flex line that looks like the one we see here on the screen, I'm really going to have that conversation about this is not going to work, right? You're supposed to get a specific amount of air out of this termination, this end, and you're not going to get there. You're going to get something, but it's not going to be enough, right? There's a difference between this and that, right? I see a straight line. I'm getting the air exactly where I'm supposed to, or at least conceptually, I'm getting the right volume of air at the end of the pipe compared to what I'm seeing in these other designs. And so again, that's what I'm looking for. I'm looking at those specific duct related evaluations. I'm also, when I'm looking at that duct, looking as whether or not it's properly sealed and insulated, right? Those are major considerations. Now we know that depending on the location inside our building thermal envelope, they may or may not require insulation. Sometimes we see them insulated simply because they want to cover a sound deafening component or a sound limiting component. Sometimes we see them, you know, again, just because they don't know what they're doing. Or if this was supposed to be completely insulated, we see where they miss some areas. So again, knowing what I'm looking for is going to allow me to better evaluate this project for success. And again, am I looking for square ducts or am I looking for round ducts? I need to know. This one is an example to me of the sealing requirements. And so I know that this is supposed to be liberally applied. And again, we look at the manufacturer. The manufacturer says it's supposed to be sealed, taped, or a liberally applied sealant, right? This right here is not going to be liberally supplied or liberally applied well enough to sustain itself against the airflow movement that's going to be going through this duct system. And so we're going to have failure in this space. Now the question becomes, where is that space in the context of the overall building? That's a whole other conversation. But more importantly, I need to know that what the methodology, or that you're following the proper methodology of sealing this system. Again, it does no good to have all that wonderful, beautiful air and energy creating the proper amount of conditioned air for it just to leak throughout the distribution system. So again, this is one of those considerations that to me is often overlooked and sometimes can be really, you know, impactful to how these buildings are going to operate for the long haul. 9 times out of 10, you're not replacing duct systems, right? Especially you're not going to open up if this is inside an enclosed cavity at some point, which it doesn't look like it's going to be. But if it was, right, if this was in an enclosed space after a while, no one's reopening this to check to see if these have failed, right? And that's why it's important to do it right the first time. And the same thing when we start talking about some of this sealing associated around the duct system. You know, remember, there are certain materials, just because they're insulation doesn't mean they're designed to be used in certain ways. And so this type of use of fiberglass insulation is not providing any level of air control or thermal control, because again, it's been stuffed, crumpled, and forced into spaces where it's lost its thermal capacity. And as a system, as a material, it's not an air barrier. So the only thing doing anything really in this area is more so the spray foam we see applied, unless this is some type of limited, again, sound attenuation. Here again, we see another not so liberally applied amount of sealant along a seam. One of the things we have to think about when we think about, you know, especially with residential designs, I see a lot of them, a lot of times I'm seeing more use of hydronic heating systems in order to provide for heating. And so again, we're not only looking at the type of insulation associated with the underlayments and those kinds of things, or the ground around that design, but we also need to think about the type of insulation being put on those pipes that carry that liquid, that fluid to those radiant systems or those hydronic heating systems. You know, a lot of times we see identified a depth, at least I see a lot of thickness calculations, right? We see here, this is a half-inch Armaflex. We see just the phrase fiberglass, right? Half inch, 1 inch, all this. Well, what we need to do is more than just provide that size, but also provide that thermal resistance value. So as an inspector, I know it's not just it's a half-inch thick, but that it's providing that R3 so that I know it's going to provide the level of condensation control that I'm looking for. But that protection that we see of those systems through against condensation is not the only type of damage we have to protect against, right? We have to protect it against solar damage, we have to protect against impact, depending on the location and the type of design. We have to protect against stupidity, right? There are times when just bad decisions are made. And so we need to make sure that when we're thinking about that design, that we're getting a design that's consistent and appears to be logically applied. And we have to recognize that not every element in our trade is in our design, not every trade within our design is going to show up at the right time. And so we want to make sure that we provide them adequate spacing and flexibility to install the different lines and not create problems. But sometimes though, when the best of intentions means we still are going to penetrate certain systems like firewalls. And so depending on a design, we may be required to evaluate those penetrations and verify that we've properly sealed them to maintain that level of smoke and flame stopping, right? That prevention of smoke and flame penetrating through those firewall assemblies. But then that firewall is just one example of the different types of penetrations that we see. We've seen these pictures before, and what this is really doing is, again, we're protecting that firewall to prevent the movement of air and smoke through the assembly. We're protecting the building thermal envelope to protect against water, insect, vermin, and heat transfer through those different penetrations. So properly sealed, properly gasketed, properly controlled penetrations are really the solution that we're looking for in those designs. But, you know, like we said, ducts and distribution systems are not the end of the process, right? We understand that there's still a requirement. We've got about 6 minutes left. There's still a requirement to identify those control systems, right? And so when we think about what those controls are doing, we've talked a lot about them in the past. But if I've got a set of controls that are designed to, again, turn on or turn off, activate, deactivate, and control that heating equipment, then I need to make sure they're installed and properly sequenced, right? And so in this example we've talked about before with this townhouse, we see in the design the designation of different fan coils as part of and exhaust fans as part of the overall ventilation and space conditioning equipment. But what we also need to make sure is that we understand where the appropriate temperature controllers are going to be, right? These are multi-zone systems, and so each zone has to have its own level of control. And so we want to make sure that does this provide adequate, does this thermostat here provide adequate control over this entire space, right? So up here we have one for each of these 3 units. Over here we've got one controlling 2 units across the main building. And down here we have 1 unit right outside the space. So again, these are things that we're making sure we have the proper location, the proper installation of these different control devices. With that, to me, I think part of this is walking this whole system backwards. We went from where the fans are to where the thermostats are. Where's the distribution line, right? That again, that hydronic piping that takes that coolant, that refrigerant, back to the heat pumps that exist on our building. So we see here the heat pumps. We see here the main, the first floor service line, taking us to those again, those different fan coil systems. But this, again, is not the only time we're thinking about it. There are other things that we expect to identify during the process of inspection. And sometimes those include, and these are just a few of them, those outdoor heating units, right? Which ones are going to be required to have inspections and permits and controls versus which are not, right? These are not because they're portable. These are because they're permanent. And that's just one place where we're thinking about, how we actually heat and cool buildings. I see this, the example we've got here is an actual commercial application, but I've had several recent plan reviews for residential that have incorporated some type of overhead or sliding glass doors or partitions that are designed to eliminate the separation between interior and exterior environments. And so when we have those types of things, an air curtain, that is not what this is, it's an attempt, right? Hope taught us about this, this attempt at providing an air curtain. It's not the same as creating that air curtain or interlocking opening controls, right? So that when these are open, the system setbacks and the system heating and cooling temperature set points are reduced. Now, again, this is one of those components of, is this something I can test? Is this something I need a commissioning agent to do? I'm going to defer to everybody else. But, again, to me, it's going to be one of those, I'm not waiting 20 minutes or 10 minutes or 15 minutes for an opening like this to activate or change that set point, right? Maybe you can show me walk me through the sequencing, show me some things like control panel. But again, for the most part, I'm going to say I'm going to need a commissioning agent or some type of a special evaluation because I'm not going to wait around for an hour. I don't have time to wait around and do all the things that we need to do. And so again, that's where we again have to understand the relationship between what we do and what we're expecting others to do as part of that process. To the extent that we do have heated pools, remember there are certain expectations even in residential heated pools and permanent or portable spas when it comes to controlling, again, the type of motor, the location of disconnects, and the types of controls, right? Or covers. So there's a couple different things we're looking for, and again, as part of that inspection, this may be something I'm looking at. I'm looking at the boiler system, or that heat pump that's firing to provide either that hot water to that pool or to that spa. And so again, I want to make sure that I've got the right things in place as I support that process. And once in a while, when I'm doing an inspection, again, this was just me, when I go out and I see an inspection going in of this piece of equipment, I noticed, well, somebody moved and did something with some insulation, right? And so it became one of those, if I'm here for this, I might as well get it all instead of saying, well, somebody touched it, but it's not my job. I'm here for the mechanical. No, I'm going to look holistically at what we do. And so if I'm doing my inspection and I notice that someone is in the process, dislodged, moved, or changed something, then I'm going to bring it up and be like, hey, make sure we fix that. What's going on? Oh, well, we moved it in order to check some lines, because that's ultimately what happened here was they moved it in order to get back in here, do some work, and then they just left it. It's like, well, this is not acceptable, right? because part of what we're also thinking about, and again, like we said earlier, this whole system only works because we have good air leakage control. And so again, that's part of what we're thinking about in this design. How do we really build a building that's going to be, again, effective at conserving energy? Now, I know I've run out of time. I apologize for that. Remember, next week we're going to get into, again, wait, that was this week. This week we talked about inspecting. Next week we'll get into skylights and fenestrations, and then get into air barriers. If you do have questions, I apologize. Like I said, I can't see the chat today. But if you do have questions, make sure you put them in the chat or in the Q&A. Those download when we save the class. And then you can also put them in your survey, or feel free to reach out to me. If you do have questions about different resources, training, or opportunities, let us know. I am thinking we're going to do something as far as coffee, Codes and Coffee sometime in late October, middle to late October. So keep your eyes open for that. I'll be reaching out to you. And we are going to be doing the TPIA training in November. I think it's November 12th, if I remember correctly. So if you do have any questions, I'll be sure to get some information out to you guys soon about that as we get closer. But always feel free to reach out to TX Helpline at Shell Dakota, or reach out to me or Hope personally. We're always here to help. You guys be careful, be safe. Sorry it took a little bit longer than I probably should have, but you guys be careful, and I will see you all next week.